Hello, my name is Sabina Johnson, and this is my final project for data structures. The problem I was trying to solve is triaging patients through a hospital system effectively based on severity and injury. When a patient arrives in the emergency room, it is crucial to supply prioritized and effective care to the patient while optimizing resources such as time, staff, number of hospital beds, etc. When a triage system is interrupted, it can result in delays, which can lead to poor patient outcomes. I was passionate about this real-world problem because I've worked in healthcare for several years prior to pursuing programming. This is a picture of me on my first internship rotation at a hospital. I've had the first-hand experience of why this is so important. My program is divided into 3 categories: the emergency room, hospital, and discharged. Patients randomly arrive to the emergency room with a variety of illnesses or injuries. They're placed into a priority queue based on illness severity and time of arrival. In my GUI, each oval represents a patient. Each patient is assigned an ID and is color-coded for severity level, with red holding the highest priority. As hospital beds become available, patients are admitted using a linked list. After treatment, they are discharged into an array list. It is crucial for hospital staff to know where patients are located within a triage system to provide appropriate treatment for safety reasons and to allow for visitors. The program allows a search feature that will display patient details, including ID, priority level, and status. Patients are added to a hash map using their unique identifier as key. The value is the instance of the patient. As the patient moves through the triage system, their status is updated. Using a hash map provides a quick lookup for finding a patient in the system. I evaluated the trade-offs between different data structures based on the specific problem I was trying to solve within my program. I used a priority queue in the emergency room because it allows my system to effectively prioritize the order that patients are admitted to the hospital from the emergency room. I used a linked list in the hospital because it is more effective when manipulating data, in this case, admitting or discharging patients to and from the hospital. I used an array list for discharged patients because I wanted to sort the patients by priority level. An array list is more effective for small-scale project using insertion sort. I used a hash map for searching patients because it does not require looping through a list to find a patient with the matching identifier. When patients are discharged, they're sorted using insertion sort. The purpose is to provide hospital administrating staff with organized data. This allows them to better allocate resources based on who they are servicing in their community. The insertion sort algorithm separates patients into 2 arrays, sorted patients and unsorted patients. The algorithm walks through the unsorted patients and places them into the correct position in the sorted array. And just for fun, I conducted a timing experiment where I compared the amount of time it takes to sort discharge patients using an array list versus a linked list. I ran the program 8 different times to capture the variety of different patient priority cases that can occur in a program. When the program sorted 10,000 patients, and an array list on average was 400 times faster, it ranged anywhere between 41 to 100 milliseconds. A linked list, on the other hand, ranged anywhere between 486 to 99 seconds. I also ran the same test for 20,000 patients, and it was even more evident then. The array list ranged anywhere between 182 to 315 milliseconds, while the linked list took, on average, about 30 minutes. I also noticed that there was a less variation in the array list with the number of times I ran the program compared to the linked list. If this program was scaled up, a sorting algorithm should be reconsidered, since insertion sort is a simple algorithm that is great for small collections. Just wanted to point out here, I'm using the MVC design pattern. I created packages to contain models, controllers, views, and tests. When a patient is created, I use the next patient ID property to make sure that patients' IDs are incremented by 1 each time a new patient is created. On the right side at the top, I want to highlight the compare to method that I implemented on the patient class. This allows the priority queue to sort the patient by the severity of their illness and the order they entered the emergency room. Notice when patients with matching illnesses severities are compared, patients with lower priority IDs receive the higher priority. The emergency room class is responsible for generating a random number of patients with random illness severities to simulate the unpredictable emergency room. So that's seen here at the bottom. One challenge I faced was displaying the patients in the emergency room. Since patients are stored in a priority queue, I was not able to loop through them to display them on a screen. The method on the right shows that I converted my priority queue to a linked list so I can display the patients on the screen. When the priority queue is converted to a linked list, the order of the patient is not preserved, and therefore patients are not displayed in the sorted order on the screen. This matches patients sitting unorderly in a waiting room. Here I demonstrate the core logic where I admit, discharge, and sort patients with each new cycle. The views are then updated. Below is the insertion sort method, which I covered earlier. The workflow controller adds patients to a hash map in the constructor. The hash map is passed into the patient search panel, allowing a patient to be displayed when a user searches for a specific ID. And here is my program. So first, I just want to point out at the start of the program, a random amount of patients enter the emergency room with a variety of different illnesses. As we run the program, the patients will get admitted into the hospital. I want to just showcase 1012 here. So patient 1012 holds one of the highest priority, which is demonstrated in red, but also has the lowest ID, meaning we should see this patient enter the hospital first. So here, as we press the cycle button, each cycle button will kind of move things along in the program. And we do indeed see that 1012 has entered the hospital here first. And then we also notice that the highest priority is entering the hospital first. The amount of beds that are available is only 50 in the hospital, so not all of the patients can enter. In addition, new patients are entering the emergency room. And this is really to kind of simulate that this is never ending. Patients are always going to come into the emergency room. So here I'm just pointing out that there's 3 more high priority level patients that entered the emergency room as we cycled through. As we continue to run the program, patients will get discharged at random, and as they're discharged, they are being sorted. Here's the search functionality. So hospital staff can search using patient ID. So in this case, we're going to search for 1090. And here it would tell us where their status is. So they are located in the hospital here. As we cycle through the program and the patient gets discharged, if we rerun that search, then the status will update. So now they're discharged, and they are indeed down in the discharged view. You can, of course, reset the program. At the bottom here, there's a patient service panel, and this is just an informational panel that tells us how many patients are located in each one of these areas, and in addition, what are their priority levels. And that panel, as you can see, does update with each cycle. And that is my program. All this code is available on GitHub, and thank you so much.